logic gates using diodes. Okay. So implementation of a logic gates using diode. So couple of gates like OR gate and AND gate, we can easily implement using logic gates. So remaining we require transistor. So here only we'll see how can we implement a AND gate and OR gate using diode. Okay. So first let us take OR gate. Okay. So we know the OR gate symbol is logic symbol is like this. If I put A and B, my output Y will be A plus B. Okay. Now A plus A and B can take high and low values and Y. Okay. So generally if you say both are low, the output will be low. If either of A and B is high, the output will be high. Similarly, 1, 0 will give you 1 and 1, 1 will give you also 1. This is your table for OR gate. Okay. So here high means 0 means low, 1 means high. Okay. High means high voltage. Okay. 0 means you can also say it is 0 volt. And 1 you can say representing 5 volt, say 5 volt, 10 volt, high voltage. Now the same output we can get using say diodes. Okay, if I say this is my input A, if I say input B, and here I put a resistance, and if I measure the voltage here, say this is my resistance R. Now for example, this is the 1 kilo ohm, say this is 1 kilo ohm. Now assume the diode is ideal. They may not be ideal, may or may not be ideal. Okay, so assume diode is ideal diode. Okay, now let us make table and see how they're implementing exactly like your say A and B and say this is V naught. Now if A is 0 volt, say A is 0 volt, B is 0 volt, then what will become? This diode cannot conduct. So this diode will be remain open circuit, and you're not getting any current because of this applied voltage. So V output is also 0. So if A is 0 volt, B is 0 volt, B 0 is also 0 volt. Okay, I hope this is you can write 0 volt, 0 volt, and this is also your 0 volt. Okay, now I will write a number. You can understand this is a volt if the space is not there. Now if I say my A is 0 volt and if I say this B is 5 volt, so if I put B is equal to 5 volt here and this putting 0, this will remain open, and this will become, because this is the ground now, this is a ground, no current is flowing. So if I make it open, so this 5 volt, this will make it short, this will be short. Okay, and with this short, this 5 volt will come here. This V naught will be equal to 5 volt, because now once you come this short, this diode directly, this voltage will directly come to this point, and V naught is 5 volt. Similarly, now if I keep here 0 volt and I make it open, if I check the open circuit voltage, this will become short and this will become open. Again, this will become 5 volt. This and this point is same. So this will be, if I put this is 5 volt, this is 0 volt. Still this is my high. Okay. Similarly, both are 5 volt, 5 volt. Then what become, both become short. So this voltage is again 5. Okay, it will become 5. So if I put a 5 volt here, 5 volt here, this will also become 5 volt. Yes or no? If I apply a 5 volt, okay, so both the diode will conduct, and both the diode will conduct. This voltage will directly come here. So this is just like implementing your OR gate. So instead of two, you can have a three diode also. Instead of two, you can have a three also. 3, 4, any n number of thing you can have. So this is implementing OR gate using diode. Okay. If you have any doubt, if you have any question, please ask. Otherwise, we'll see the AND gate and we'll solve some problem based on this concept. Is it okay? Now let us say AND gate. So AND gate using diodes. So this is your AND gate and this is your Y. If 0, 0, 0, if anything is 0, this will become 0, and both are 1, then only become 1. Now we have to implement this using a diode circuit. So say this is my diode. Okay. Here a resistance is there. I'm applying here, say VCC 5 volt. I'm applying here. Say this is my 1 kilo ohm resistance. And say this is also my just wait for 1 minute. Okay, let me write it first properly. This is okay. And if I connect like this, and this is ground, and let me put this resistance here. You put a resistance here and measure V naught here. This is 1 kilo. Now let us say what happened. Here you have A and you have B. And now again you make the table and we see how does this circuit works. You have A, B, and you have V naught. If I say A is 0 volt, that is grounded, and B is also 0 volt, grounded. If it is A is 0, B is 0. Now both become grounded, so I can replace both by short circuit. This will be short circuit. This will be short circuit. Okay. Current will go here. So no current is coming here. No current is coming here. That means V naught is also 0. Because if this is like this, okay, this circuit will become short from here. So you won't get any voltage across this RL. Because this circuit complete like this. Just let me check whether it is correct or not. Circuit is correct or not. If I put resistance here, and if I measure the voltage here, V naught here. So this current will pass through here. All the loss will become here. Here I will not get it. Just give me 1 minute. Let me check the circuit of OR gate, whether I'm doing right or wrong. Give me 1 minute. Just. Okay. So we are little bit doing mistake. Let me correct that mistake. Correct that mistake. Okay. So basically, this is the circuit. This is your circuit, and I'm measuring V naught with respect to this ground here. And here you have here it is correct. This is your diode, and this is your diode. Okay. Now, if it is a and this is a 1 kilo ohm, I'm measuring voltage here. So if this circuit become complete, if this is short circuit, this becomes short. Okay, this becomes short. So current will go from here to here, okay, or here to here. No current will go here, so no drop is now. This is short circuit because this is short, so this become ground. This is short. This is short, so this become ground. So your V naught becomes 0 volt. Okay. Now let us say if I say this is 5 volt. If this is a 5 volt and this is a 0 volt, this is a ground. So this becomes short, and now 5 volt. This will become open because here is a 5 volt, 5 volt, 5 volt, 5 volt. So this will become open, but current can still go like this here. So all the voltage drop will happen. This is now this is a ground. This point is ground. At this point is ground. So this all the voltage drop is here. V naught still you're getting 0. So if it is 0 volt, it's a 5 volt. Still you're getting 0 volt. Third case, if this is a 5 volt, this is a 0 volt. Same thing, you get a 0 volt. If both the volts are 5 volt, 5 volt, okay. If this is also open, this is also open. So this circuit is open, so current cannot pass because everything is open. Here is open, this is open, this is open. So no drop here. So this voltage will directly come here. So you'll get high voltage. Okay. So this is your implementing AND gate using diodes. Okay.
सर पहला वाला केस थोड़ा समझ नहीं आया सर.
पहला वाला 0 वाला ना.
हाँ सर.
So if this is a 0 volt, that means this is the ground because this point is high, this is low. Open circuit voltage is making it forward bias. This is also ground. Okay. So now this point is 0 volt. So this point is 0 volt. This is also ground. So all the voltage is getting drop here. Now V naught is connect directly to 0 volt. V naught is directly connected to the ground. This is directly connected to the ground from here and from here. So V naught is 0. Okay. Second case, this is short, this is open, but still this V naught is this point is 0, this point is 0, this point is 0, and this point is 0. Again 0. Same thing with third. When both are 5, 5, 5. Now current cannot go here. Here it cannot go, here it cannot go, and here it is also open. Current will not flow. So there's no voltage drops. This voltage will directly come here, so it will become 5 volt here.
सर केस 2 थोड़ा रिपीट कर दीजिए. केस 2 में फर्स्ट
वन इज क्लोज.
सर ए में ए में 5 वोल्ट थी.
So A में 5 volt. Third case. So A is 5 volt means this is open because this is the 0 volt. So A is closed. This is open. This is a 5 volt.
Okay.
Again, this is ground, na?
This is ground.
Yeah.
मतलब कोई भी एक टर्मिनल में 5 वोल्ट होने से वो एक्ट नहीं कर रहा है, ओपन हो रहा है. दूसरे टर्मिनल से करंट फ्लो हो जा रहा है. तो इनका वोल्टेज माने V0 के अंदर कोई ड्रॉप नहीं हो रहा है.
कोई ड्रॉप नहीं हो रहा है. Okay. Yeah. Because all voltage coming, current flowing means drop is here. So all 5 here, it is 0 because this is directly connected to the ground. This is directly connected to the ground.
Ground. Got it.
So this is your AND gate. Now let us see some problem based on this AND gate. Now say you have a diode. I can use, instead of 2, I can use 3 also. And say here, this is 5 kilo ohm. Here I am putting 3 volt. Here I am putting 2 volt. Here I am putting 1 volt. Okay. Tell me what is the current in the resistor and what is the V naught. So what is V naught and I in the current? Tell me. This is 1 kilo ohm. So it is 3 volt, 2 volt, and 1 volt. So which diode is conducting? Just look it and tell me which diode is conducting. Whether all are conducting, nothing is conducting, or only one is conducting. Tell me by looking this one. Apply the logic. So this is diode D1, D2, and this diode D3. If I say all are conducting, can all can conduct? Tell me, can all can conduct? If all is conducting, then what will happen?
D1 is conducting.
D1 is, because if I say all are conducting, then this is short, this become 3 volt, this become 2 volt, this become 1 volt. This cannot happen. Okay, one point cannot have a 3 voltages. One point can have only one voltage. Okay. So if I say this one is conducting, then what will this 1 volt will come here? Yes or no? This is one is coming. This is 1 volt. This is 1 volt. 3 minus 1. This is also conducting. This is also conducting. Then again the same problem. Listen, if I say this D1 is D3 is conducting, then this point become 1 volt. Now 2 minus 1, this is also conducting, and this is also conducting. All are conducting. So 3 volt will come here, 2 volt will come here. This cannot happen. Similarly, if I say my D2 is conducting, then this 2 volt will come here. And then this is also, then 3 minus 2, this is also forward bias. So this also, so this 3 volt will come here. Of course, this will be open, but this is still there's a problem. If I say only this is conducting, so what will happen? 3 volt will come here. Okay, 2 volt minus 3 volt, this is open. 1 volt minus 3 volt is open. Now there is no problem. That means only D1 is conducting. Only higher voltage will conduct in the expression for OR gate. Only D1 is conducting. And when D1 is conducting, this becomes short, this become open, this become open. So now this V0 become 3 volt, and the current I become 3 upon 1000, that is 3 milliampere. This is the answer. Now let us take second case. When I say, now this was the OR gate. Now let us do same thing with your AND gate. Okay, say this is my diode, this is my diode, and this is my diode. These all are conducting. Okay, I am measuring the voltage here with respect to the ground. This is say 3 volt, 2 volt, and 1 volt. Here a resistance of 1 kilo ohm, and say this is 5 volt. Okay, tell me which is conducting. Which is conducting now?
D3.
So this is D1, this D2, and this is D3. If I say all conducting, then this point becomes 3 volt, 2 volt, that will not possible. That means two simultaneously cannot conduct. Okay, if two simultaneously conducting, then this voltage becomes cannot be 2 volt. This will be only 1 voltage. Okay, so if I say 3 volt, this is conducting. Okay, then current will flow. Then this will be also conducting. So that is not possible. This will be also conducting. This is not possible. Similarly, if I say this is conducting, then this 2 volt. So this is also conducting. So this is 1 volt. This is also not possible. So only possible is D3 is conducting. So if D3 is conducting, this become 1 volt. Okay, so only D3 is conducting. And once D3 is conducting, this point become now 1 volt. And now there is no issue. This will be open circuit. This will be also open circuit. So current will pass from here only. So now the current will be how much? This is 1 volt. What is the current? Tell me here. Now current you're measuring here. What is the current? So I will be 5 minus 1 divided by 1 kilo ohm, that is 4 milliampere. Okay, and what is the voltage V naught? Tell me, what is the voltage V naught?
Oh,
What is the V naught? Tell me.
4 volt.
How 4 volt? This point is connected to this point. What is the voltage at this point? What is the voltage at this point?
1
If
Sir,
volt.
1 volt.
1 volt. 1 volt. So this way,
Sir, how
you
to
can,
come D3 1 volt only, other are not conducting?
because if I say this conducting, so this point become 2 volt directly connected to this, which is short. So this become 2 volt. And when I say this 2 volt, here is 1 volt. So 2 minus 1. So this is also conducting. So this also become 1 volt. So same point cannot have a same voltage, na? So at a time only one can conduct. And now you decide which will conduct. Now, if you say this is conducting, so automatically this is also conducting, this is also conducting. 3 cannot conduct simultaneously. If I say this conducting, then this is also conducting. If I say this conducting, then these both are open. That is possible because now this voltage is less than this one and this one, so they can be open. So only this is conducting. Lowest one conducting. So in OR gate, highest will high voltage, higher voltage conduct. Here lower voltage will conduct this thing. So you get now this 1 volt.
Okay.
Now, let us say last topic is there, diode.
Excuse me, sir.
हाँ,
सर इसका एक और एग्जांपल बता दीजिए सर, थोड़ा समझ में आ जाएगा
OR गेट का एंड गेट का.
सर
से
अभी जो बताया रैंड गेट का.
this is say 5 volt is the 1 kilo ohm. Okay, this is 2 volt, this is 1 volt. Okay, and here I am measuring the voltage with respect to ground. Okay, अब बताओ कौन सा कनेक्ट करेगा, which will conduct, D1 or D2?
D2.
सर D2.
D2,
D2.
because D2 will conduct. Na? If D2 conducts, then this become 1 volt, and now this is also 1 volt. So 2 minus 1, this become open.
सर एक क्वेश्चन है. अगर ये D1 D2 के बीच में जहाँ पे कोई रेजिस्टेंस नहीं है, उसके बीच में अगर कोई रेजिस्टेंस दिया जाएगा तो क्या होगा?
वो तो देखना पड़ेगा सर्किट क्या, फिर आगे क्या होता है. फिर तो वोल्टेज अलग हो सकता है ना, फिर तो हो
हाँ,
सकता है.
उस टाइम पे तो दोनों ही कांटेक्ट कर सकता है.
वो देखना पड़ेगा कि उसका क्वेश्चन क्या है, वो फिर अलग क्वेश्चन हो जाएगा. अगर आप बोल रहे हो ऐसा ऐसा केस है, ओके,
यस सर.
एंड दिस इज डायोड इज देयर, then this become different things, then this become different. Okay, say this is also 1 kilo ohm. Now you have to again find the open circuit voltages across. Say this is open. Okay, if this is open, so no current is flowing here, and this is also open. If both are open, then what will happen? This current can flow from here to here, here to here. So now if I find a current, this is two current will be how much? Current will be current cannot pass here also, na? Here also, if both are open, current cannot pass, because here also open, here also open, this current cannot pass. So no, this voltage directly will come here, and this voltage directly will come here. So if this voltage is come directly here, then this is conducting. So that is both cannot conduct. That is wrong. If I say this is conducting and this is not conducting, then what will happen? Tell me. If this is conducting, so here no current will go. Only current will go from here to here. Okay. So all the drop will be here only. All the drop will be here. Here no, here will be no drop, because current is flowing here. No drop. If I say this is conducting, then this is open, so current will not go here, current will come here. and all the voltage will drop here. This will be ground only. This will be ground only. Okay. And when I say this is conducting, then what will happen? If this is conducting, so this 2 volt is here. Sorry, this 2 volt is here. This is conducting, this 2 volt is here. So this is 2 to here, no current. This 2 to same thing. 5 minus here current will go. Here there will be no drop. Okay. And this current will go here. So you have to see like this. What is the question? We'll see that one. If I find some questions here like this, we'll see that what happened in that case. Okay.
Okay, sir.
So that have to see question like that. Okay. Then last is your small signal model. Small signal model means, suppose you have a diode. You have a here diode, and you are applying some battery to this diode. Okay, so of course some resistance is there. Say some resistance is there. Now, if I measure the IV characteristics of this diode, okay, say you are changing the voltage also. So now, if I draw this VD versus ID, this is my ID and this is my VD. So this is my forward characteristics. This will be my curve. Exponentially current will increase. Okay. Or if I apply some fixed voltage, okay. So if at fixed voltage, I can find the DC resistance of diode. So DC resistance of diode, DC resistance of diode. Okay. So DC resistance of diode will be what much? What is the VD here and what is the ID flowing at a particular voltage? Okay, this VD is not fixed. This is varying, little bit varying. If VD is this one, then current will be this much. So this is called DC resistance. So DC resistance of diode is defined as VD by ID. How much current is flowing? Suppose if I apply a fixed voltage here, then we'll see how much voltage drop here. We'll measure this voltage here and correspondingly measure the current. Okay, and that the ratio will be your VD by ID. This is a DC resistance. Now what I do, along with this DC source, if I put a small AC source, so this is your DC resistance, RD VD upon ID. This is my DC resistance. Now in this circuit, if I put a small battery, this battery is present, plus I put a small signal VDT, a time dependent voltage. Okay, this time dependent voltage, say here I am applying, and this is my 0 point. This is my point here where the voltage is VD, and I am putting a line here. Now along with this one, I am putting a small signal, AC signal. So when this is the positive part, this voltage will become higher. This plus this will become higher. Yes or no? Now this is a small AC signal. So suppose this is a 5 volt and this is a 5 millivolt. 5 millivolt up, 5 millivolt peak to peak voltage. So when this is a 5 volt, now this will become 0.1 1 millivolt. This will become 5 plus 1 millivolt, 5 plus 2 millivolt, 5 plus 3 millivolt, 5 plus 5 millivolt, positive voltage. So voltage is increasing. So the drop also here will little bit drop will also increase. So my current will also increase. So now say this is my point. Okay. Now I'm applying some small amplitude. Because of the small amplitude, this point is shifting. This point is shifting. If you're applying positive peak, is going up. If you're reducing this voltage, this ID will drop. Okay, because this is your IV, this is the IV characteristics. Now if you change if a little bit VD changes with applied voltage, so the VD changes, then this point will shift. If it increasing, it should go here. If VD is decreasing, this point will go down. Okay, but you're applying very small magnitude, so what will happen? This point in the circuit will this current will change. So that means when you are applying, say, a small AC at this point, okay, this current will become here. When it is zero, current remains zero, and current remains zero, and if you increase the voltage, current become down like this. Okay, you have to see when this point is here, you have your point is here. Now if you say you're applying this point, okay, this point will go here, so the current will increase here, and when you go down, okay, so with down, this point will come here, so you current, this point will become here. So with this applied voltage, this point is shifting. You should understand what I'm saying here. Okay, it's not clear in the circuit diagram, but you understand. If with this, along with this, if you are applying this one, then this point is shifting up and down. Okay, that means what is happening? Current is changing with applied voltage. Now in this case, if I measure delta VD by delta ID, if I measure delta VD upon delta ID, that is called AC resistance. That is called AC resistance of diode. AC resistance of diode. AC resistance of diode. And now I am interested in this AC resistance for a small signal, not completely AC. Completely AC case we'll see later. Okay. Now this is only for a small signal. If it is a volt, it is a millivolt. What is the small change in the voltage, small change in the current? What is the ratio? That is called the AC resistance. Okay. So let us first calculate what is AC resistance. Now say this is my equation of, and only forward direction we are measuring. Okay. Now ID is what? ID is exponential QV eta KT minus 1. This is my diode equation. Okay. Now for forward bias, I can write my ID is equal to I naught. I can neglect this one. This become exponential Q VD upon eta KT. What is the drop across the voltage? What is the current? I naught is a reverse saturation current. Now differentiate this one and calculate delta VD upon delta ID. Tell me what is coming. Differentiate and tell me what is the value. So delta ID upon delta VD, I naught, if you do exponential, this will come Q VD upon eta KT only. And if you differentiate with VD, this will come Q upon eta KT. And now this expression is basically ID. This expression is ID. This ID. Okay. And this is your Q upon eta KT. Now here, this is your 1 upon, now I want RAC. So RAC is delta ID by delta VD upon delta ID. That is eta KT upon Q ID. Okay. And now if I take eta equals to 1, eta value can be anything, then what will happen? This KT by Q upon ID, and KT by Q ID is what? Let me eta remain now. KT by Q is VT. thermal voltage, eta Vt upon Id. And Vt is the thermal voltage. Vt is what? Kt by Q at 300 Kelvin degree at T equal to 300 Kelvin. This is equal to, we have already solved. This is almost equal to 25.9 or 26 millivolt. So basically, this is your formula for RAC. Now, eta will be given in the question, whether it is a 1, 2, eta value will be given. For at room temperature, Vt is 26 millivolt, and ID is this current across which you are shifting the point, this point ID. ID is a DC current. ID is the DC current. Now, what does this mean? If you have a circuit, in that circuit there are two sources, one is DC source and one is the AC source, okay? And you want to see the effect of AC source. So first you have to solve for this circuit for DC and find out ID. Okay, once you know the ID, after that you can find the diode resistance and you can replace this diode with this resistance. So now finally, what is the meaning? What is the meaning is this? If you have a circuit with a battery plus small VDT, okay, and you have a diode, some resistance here, you apply superposition principle. First you say this is not present, and now this will become what? This will become, and this will become only battery, and now you find ID. Okay, once you have find out the ID, okay, now you know.
Excuse me, sir.
Tell me.
सर हम वोल्टेज सोर्स को तो शॉर्ट ओपन सर्किट करते हैं ना?
किसको शॉर्ट सर्किट करते हैं? सुपरपोजिशन प्रिंसिपल ना, करंट को ओपन करते हैं.
Okay, sir.
So I have removed this source, okay, and I'm seeing the effect of this one. I am calculating ID. Once I know the ID, using this formula, I can calculate the resistance of the diode. Okay. Second time, what I'll do, I'll remove this one, and I'll put only this BDT. Okay, and I will replace this diode by a resistance, and I can find the voltage drop across this resistance because of this AC source. Okay, let us do this one question. You understand how we are going to do. So first you have to do DC analysis, and that later you have to do AC analysis. Okay, so a small signal model means, number one, first you apply DC, you do DC analysis, and second you do AC analysis. Okay, and you know what is meaning of DC resistance and AC resistance. So first we'll calculate DC resistance and AC resistance, and then we'll see how to solve the circuits. Say, it says calculate static and dynamic resistance of diode. Static means DC, dynamic means AC, resistance of the diode, okay, of a PN junction, okay, at 27 degrees centigrade. You have to calculate the static and dynamic resistance of the diode or PN junction and for that you have been given temperature is 27 degrees centigrade, that is 300 Kelvin. Okay, and reverse current is given IS. IS is reverse saturation current, I naught, which is equal to IS reverse saturation current, that is given 1 microampere, and the applied bias voltage is applied forward bias voltage, that is VD, is given forward voltage VD is given 0.2 volt, that is given to you, and now you want to find that DC and AC resistance. Calculate. So the equation is ID equals to I naught exponential QVD upon eta KT, and eta is given 1. Eta is given 1. So you need to solve this equation neglecting 1. So basically you want DC resistance RD equals to VD upon ID, and VD is given you 200 millivolt. So you want fund to find ID. I naught is given 1 microampere exponential KT by Q. KT by Q is how much? Tell me. KT by Q is how much?
26
26 millivolt. 26 millivolt. VD is 200 millivolt. Eta is 1. Tell me what is ID. Tell me what is the approximate value of ID. This become exponential how much? 26 200 divided by so it will go 7 1 into 10 to the power minus 6 exponential. How much? 7 point or 8 point? 7 point. 200 divided by 26. 7 point. I have answer 7.69. Correct है क्या?
Yes.
Now find the, tell me the what is the value of ID. It's a milliampere or ampere, microampere. What is the value? Exponential 7 कितना होता है? 7.69. Ramya? Exponential 7.69, how much is there?
186.2.
Amardeep?
So 2186 था
Current आ रहा
2186
2.1. I am saying
current
2.86 ना?
exponential. Yes sir.
So this is milliampere or ampere?
सर एम्पियर हो जाएगा ना.
Exponential 7.6 कितना होता है? Exponential 7.6
milliampere हो जाएगा.
milliampere. Okay, so this is current is because this is 10 to the power minus 6 and something here. So this will be your current. Okay. Now tell me what is the static resistance RD? RD will be what? VD. VD is 200 millivolt and the current is 2.1. You can please check the value. I don't remember the value. Milliampere. So this will come around 91 point some ohm, 90.53 ohm. You can check and tell me what is it correct or not. DC resistance. अब कैलकुलेशन तो तुम ही करके दिखाओगे थोड़ी मेरे पास यहाँ बैठे कैलकुलेटर करूंगा मैं. योशिता, is it correct?
सही है. 91.53.
Okay, so this is your diode resistance, DC resistance. Now I want a AC resistance. What is the formula for AC resistance? AC resistance, this is eta Vt upon Id. Eta is 1, Vt is 26 millivolt, and the current is Id is what? 2.185 milliampere. How much is coming? 11.89 ohm. Okay, whatever answer I'm writing, you have to check. 11.89 ohm. Tell me now if you have any confusion or it is clear. What DC resistance was AC resistance? So for AC, you always first have to do DC analysis. Kashish, Karishma,
Yes, sir.
is the point clear?
Yes, sir.
RAC 9.15.
AC, how, what are you saying? Your voice is not coming properly. Let me loud.
So this RAC is equals to 9.15 ohm.
9.15. Okay, that I don't know actual calculation. You can check it. This 91.5 is DC resistance. And if this current value is correct, then you can solve this one. I don't know how much will come.
सर आरएसी जो हमने कैलकुलेट किया है वो रूम टेम्परेचर लिया है 27 डिग्री, मतलब T इक्वल टू 300 केल्विन में।
या
तो अगर क्वेश्चन में टेम्परेचर दिया जाएगा, मतलब T का वैल्यू 300 के अलावा दूसरा कुछ वैल्यू दिया जाएगा, तब हम लोगों को
तो इसको निकालना पड़ेगा।
ओके,
KT/Q को रूम टेम्परेचर इसका वैल्यू फिक्स है।
गॉट इट सर।
अगर नहीं समझ में आ रहा है तो क्वेश्चन पूछो, क्योंकि बिना क्वेश्चन पूछे तो कुछ काम चलेगा नहीं ना।
सर KT/Q में सर Q की वैल्यू कैसे रखेंगे?
Q की इलेक्ट्रॉन का चार्ज
गिवन होगा तो
1.6 × 10⁻⁻19 चार्ज ऑफ
अच्छा।
इलेक्ट्रॉन। करंट तो चार्ज इलेक्ट्रॉन से बनी होती है ना।
हाँ सर, मतलब एक ही इलेक्ट्रॉन का चार्ज रखना है।
मतलब करंट फॉर्मूले में आपको खाली वैल्यू इलेक्ट्रॉन की लिखनी है, एक ही इलेक्ट्रॉन नहीं है, थर्मल वोल्टेज का निकलता है, ऐसे ही है। ओके, नाउ लेट अस से, now we'll see how to solve the circuit. Say I have a 10-volt battery and I am applying a small amplitude Vi equal to 1 sin omega t. Okay, and here I have a resistance 10 kilo ohm, and here I have a diode. Okay, like this circuit is there. Now question पूछ रहा है what is the AC amplitude across diode? What is AC amplitude across diode? Okay, amplitude means amplitude is 1. Here you are applying a small signal of 1 millivolt. This is a 1 millivolt peak to peak value. So when you apply 1 millivolt across the diode, what is the voltage? That is asking. So first thing, what you do, you will replace the diode by a resistance. Okay, so what is the DC resistance? What is the AC resistance of diode? First you calculate the ID. So first step 1 is DC analysis. That is calculate ID. What is ID? Now this diode is made of, say, silicon. Okay, this diode is made of silicon. This is a silicon diode, and eta value is given 2. So now this diode is forward bias or reverse bias? This diode is forward bias or reverse bias?
Forward.
So forward.
Sir,
yes.
forward bias.
So then replace it by
Short circuit.
no zero. It is silicon diode now, na? 0.7 volt. If it is ideal, then you can replace short circuit. But they are given the silicon diode, so you have to replace by 0.7 volt. Okay. Now, what is ID following in
Sir,
the circuit?
Sir, just 1 minute. ऊपर में आपने क्या लिखा है? What is AC?
Amplitude across diode.
Okay.
So now, what is ID in the circuit? Tell me. What is diode current flowing through the diode?
9.3 upon 10 kilo.
So ID will be 10 minus 0.7 divided upon 10 kilo ohm. That is 9.3 upon 10 to 10 raised to power 3. That is 0.93 milliampere. Yes or no?
Yes, sir.
Okay. Now second step is, once you know the ID, second is find AC resistance. Okay, what is AC resistance? RAC eta VT upon ID. Eta is given to VT is, you can, if it's not given, you can take either it will be given 26 or 25. If not given, you can take 26. Okay, so this is 26 millivolt and ID is 0.93 milliampere. How much is coming RAC? Tell me.
5.59 ohm.
Okay, 5.59.
59.
5 ohm.
Yes, sir.
5.5 ohm. Okay.
55 point.
Okay. Whatever.
5.59 ohm.
9 ohm. This become RAC. Okay. Now do it. AC analysis. So now replace this by this resistance by a 5.
55.9 होगा सर.
55.9. Because
Sir, 55.9 ohm आ रहा है.
कितना
55.9.
हाँ दिखाना मैंने. प्लीज कितना, ये यहाँ से कितना आ जाएगा? 52 divided by 0.9, so 50 something greater than 52. 55.9. Okay, now this is 55.9 ohm. Okay, now you want to find what is the AC amplitude of AC here. So amplitude of AC voltage, AC voltage ने पूछा, amplitude पूछा है. So now this 1 millivolt, this amplitude, it is getting divided here. That will be equal to 1 millivolt amplitude. It is getting divided between 10 to the power 4 ohm plus 55.9 ohm into 55.9. Tell me what is the voltage value? Is a microvolt or millivolt? So this should come in microvolt. I have the value answer something 5.35. It may will change. Tell me what is the value. So this is 10 raised to power minus 3.
5.56.
5.56 microvolt. microvolt. Okay, you can neglect this part. So this becomes 10 raised to power minus 6. 6 into 10, 5.59 microvolts. Correct. Somewhere something around this will come. Now I'm giving you one more question so that this concept should be clear. This we will use in the transistor, okay? These things will be used in transistor. That's why I am dealing with small signal model. Now say I have a DC voltage of 12.7 volt. AC signal is 100 millivolt. Okay, so V input is Vp sine omega t and amplitude is 100 millivolt. And here you have 9,900 ohm, and you have here 4 silicon diodes. Silicon. You have to find the AC voltage across these all resistance. Okay, find a amplitude of AC. AC volt output. AC voltage amplitude you want to find here. Okay, do it again the same way. First you do the DC analysis and then you do the AC analysis, and eta value this time you can take 1, and this VT you can take 25 millivolt. Solve. Hmm.
सर ये सिलिकॉन डायोड है तो?
Silicon diode. So first remove this one. Now find out whether these diodes are conducting or not conducting. If it's a conducting, replace by all by 0.7 volt, 0.7, 0.7, 0.7, 0.7. Okay, and now calculate the ID flowing here. So ID will be what? ID will be 12.7 minus 2.8. 2.8 divided by 9,900 ohms. Okay, that will become how much? Tell me. कितना आएगा ये?
Sir, 1 milliampere.
Okay, 9.9, 9,009. Okay, so this will come 1 milliampere. Okay, now you can find the RAC. RAC will be eta VT upon ID. Eta is your 1, VT is 25 millivolt, ID is 1 milliampere. So this will come 25 ohm. Now you remove this one and put it plus source of 100 into sine omega t, 100 millivolt. And now each diode will be replaced by a 25 ohm, 25, 25, 25, 25, 25 ohm, 25 ohm, 25 ohm, 25 ohm. Okay, combined these are 100 ohms. Combined these are 100 ohms. And now find the AC amplitude. So now this become 100. Now AC amplitude across diode, AC amplitude across diode is equal to how much? 100 millivolt will be divided between 9900 plus 100 into 100. कितना हो जाएगा? 10 raised to power 4 and 10 raised to power 4 into 10 raised to power minus 3, that is 1 millivolt is the answer. If you have doubt, please ask. Otherwise, we'll go to the next question. Tej Kumar,
Yes, sir.
clear?
Yes, sir.
So we have almost completed our diode. Now I will want to solve some previous year questions. I'm rubbing this one. Kashish. So you always, whenever you want to do AC analysis, you have to junction, you have to replace with the diode, okay, in forward bias. Now, the question is came in NET JRF 2017, NET JRF 2017, okay. This says they have given the reverse saturation current is, they have given a PN junction, okay, reverse saturation current is given. Reverse saturation current is given as I naught. Okay. So you have a junction. So one time you are making this junction forward bias, you are applying VF, and second time you are applying, making this junction as a reverse bias, and you are applying a voltage VR opposite to this one. Okay. Now is asking find the resistance ratio, reverse resistance to the forward resistance of the diode, ratio of the reverse resistance to the forward resistance ratio you have to find. Okay. And for that they given the eta is given ideality factor. Eta is your ideality factor. Ideality, how much the deviation from ideality. If ideal is 1, and depending on the deviation, it may be 2, 1.5, 1.6. So eta is a ideality. Okay. And now I know that how to find ID is given by ID is equal to what? I naught exponential QVD upon eta KT minus 1. This is the equation. And if I want to find the forward resistance is what? RF is what? RF is VF upon ID. If you're applying forward voltage, VD is VF, then my ID will be what? My ID will be I naught exponential QVF by eta KT. In forward direction, I can neglect this one. Yes or no? Tell me, yes or no?
Yes.
So this is so I will say now this is the forward current. I will say IF. Okay, VF by forward current. So my RF will become what? My RF will become VF upon IF I naught exponential QVF by eta KT. This is my forward resistance. Now I want to find the reverse resistance. Okay, how much current flows in the so here the current is flowing IF. Okay, which is ID equals to IF in forward direction. Reverse direction, how much current flows? Tell me. Reverse current, how much current? Reverse current is equal to, tell me how much? Remember the graph. This is the forward current. This is the reverse current. So reverse direction, the current is only equal to I naught. So if I want to find for reverse resistance RR, okay. So in the reverse current IR will be what? Reverse current IR will be, you have to put here I naught exponential minus QVR upon eta KT minus 1. Now this factor becomes 0. So reverse saturation current is only equal to minus I naught. Only this much current flows in the reverse direction. Reverse saturation current, and that is also opposite direction. So IR will be minus I naught. Now if I want RR is what? VR upon IR. That is VR upon IR is minus I naught. Okay. Now let us find the ratio RR versus. This point should be clear to everyone. Current is this one. Opposite direction. Now if I find the ratio RR versus RF, that is VR, minus sign you can remove because you're calculating resistance, so minus sign you can remove because you are calculating resistance only. So now VR upon I naught divided by, this is VF divided by I naught exponential QVF upon eta KT. So now this I naught will cancel. So you will get VR upon VF exponential minus QVF upon eta KT. Okay. And this is given as an option D. So this is the ratio, and this is given as an option D for this question. And this is the correct answer for this question. You can check it. Previous year questions, there you can find. Tell me if someone has doubt. इस क्वेश्चन में किसी को डाउट है क्या? Okay, let me solve one more problem from previous year. करिश्मा, आगे चले?
Yes, sir.
Because when I'm calculating current, this is my diode, and I'm applying voltage like this, VR. And my current is like this also here in this direction. So I'm calculating VR upon IR for RF. Okay, I'm not putting minus sign because I'm only calculating the resistance value here. So the next question is, you have a 24-volt battery. Now you have to solve this one. Okay, 12 kilo ohm, 6 kilo ohm diode, 3.3 kilo ohm, 3.3 kilo ohm, Okay. He says in the following circuit, the voltage level of the diode is forward bias condition is 0.7. He is asking what is the current is flowing across the diode, and this diode is silicon. This diode is silicon. Find out how much current is flowing. So these type of questions, I told you how to solve this type of questions.
First DC analysis.
DC analysis. DC analysis. Okay, this is only DC only. You can use the Thevenin equivalent circuit to simplify the circuit. You can directly find how if it is a diode forward bias or reverse bias. If it is forward bias, you replace by 0.7 volt, 0.7 volt directly, or you make a Thevenin. You remove this branch completely here, and find out Thevenin equivalent, and then put it back this circuit, and then find what is ID. Tell me what is the value of ID. So let me make it Thevenin equivalent circuit of this one. I will break this one from. I will break from this one from here, and I'll find what is the open circuit voltage here V Thevenin. So V Thevenin will become, tell me, 24, 12 plus 6, 18 kilo ohm into this 6. This is across 6 kilo ohm. This is 1, this is 3, this is 8. So this is the 8 volt. And what is R Thevenin? R Thevenin across this one. If I make this short circuit, then this resistance is parallel to this resistance, and this is R Thevenin. R Thevenin is 6 kilo ohm parallel to 12 kilo ohm. That is 6 into 12 upon 18. That is 3, and it is 4. That is 4 kilo ohm. Now my Thevenin equivalent circuit will become, this is coming 8 volt. R Thevenin is 4 kilo ohm. Okay, and my diode, whatever removed, I am putting back putting it back with a 3.3 kilo ohm resistance. 3.3 kilo ohm resistance. So this is the equivalent circuit. Now I will see this whether this diode is forward bias or reverse bias. It is forward bias or reverse bias? Make it
Forward
open, forward bias. Now replace it by a 0.7 volt battery. And now you can find what is ID or I flowing through the diode. So ID will be what? ID will be 8 minus 0.7, and this will become 7.3 kilo ohm. So 8 minus 0.7 is 7.3, and 7.3 kilo ohm. Cancel out, this will become 1 milliampere. ID will be 1 milliampere. And this is given as the option B. This is given as the option B. And this problem came in the GATE 2012. Okay. So there are more problems. Please try to solve other problems. If there is any problem you're not getting, you tell me. And if you want a doubt class, tell me in the advance, so that before going to the transistor, we can have a doubt class. Otherwise, tomorrow I will start transistors. Okay. Inform me before. Okay. If you want a doubt class, you inform me in advance. So I'll stop here. Thank you.
Thank you, sir.
Thank you, sir.
So tomorrow transistors. Okay.
Yes, sir.